Here is a good representation of a trigonometry grade 11 examination question, just to remind us of some important concepts in trigonometry. So in general, the questioning is like this. So you get diagram type questions. A question like number 1 is a diagram type question. So I know that to answer this one, I must draw a triangle by connecting the given point to the x-axis and making an angle of 90 degrees. Then the numbers, the coordinates of the point given, we use them to label the diagram. So the first one is x and the second one is for y. Then I calculate the third line using the theorem of Pythagoras. Then from there I can go ahead to answer all the questions by doing substitution, taking values from the diagram. Then what else is being tested here? If you see 108 degrees, you must remember reduction formulas. The 180 falls away. I remain with cos theta, which I must check if it's positive or negative according to the cast diagram. Then the next one, we have general solutions. I need to know the moment you see an equation with the sine and cos, one is squared. You solve it by substitution. You have to remove the squared one and replace it with an equivalent expression that we get from the identity. Once we do that, it becomes quadratic. We express it in standard form, solve by quadratic formula, by factorization, by completing the square, whatever method you are comfortable with. Then question number 3, if you see 90 degrees, 90 degrees falls away and the sine changes to cos, cos changes to sine. Then 180 is reduction formula, we have mentioned that one. A negative angle, negative angles are in the fourth quadrant. So when you are working with a negative angle, the negative simply becomes a coefficient for sine x. So that means the sine of negative x is the same as negative sine x. Then the tan of negative x is the same as negative tan x. Then the one for cos negative x, the negative simply falls away because in the fourth quadrant cos is always positive. Then the last question in this case is identities, proving identities. I need to know that if I'm working with a fraction a over b plus or minus b over minus c over d, let's say I am working out an expression where I must add fractions. We have one general rule for fractions. To add fractions, you make the denominators the same. So if I get a over b plus c over d, I multiply the denominators b times d. That will become my common denominator bd. Then I cross multiply a times d to get ad plus b times c to get bc. Then I can simplify and substitute with whatever I had to make sure that my identity is proved. This is a trigonometry grade 11 mathematics paper 2. So the moment I read my question, ideas must come into my mind that way if I have done enough studying. So let's have a look at how we can answer this kind of questions, and we can use them as examples in your study and revision and preparation for mathematics paper 2 grade 11. Question 1. If you get a diagram like this one, you connect the point given to the x-axis to make a 90-degree angle. So we draw a perpendicular line from point P to the x-axis, please, to the x-axis. This creates a right-angled triangle. Then the two numbers that we are given here, the coordinates of P, the first one is x and the second one is y. Those two numbers, they give us two sides of the triangle. The first one is x, which is along the x-axis. It means from O to x there is 1. Then the next one is the vertical line, so this is equal to 3. This is a right-angled triangle. Now, in a right angle triangle, we apply theorem of Pythagoras to calculate the third side, and we apply trigonometric ratios to calculate the angles. So we can apply trigonometric ratios to calculate the angles of the sides, and we can apply theorem of Pythagoras depending on the information provided. So given that we have angle theta, with reference to theta, we have this side is the adjacent, and we have the opposite, and we have the hypotenuse of the triangle. We know from what we have studied that trigonometric ratios, the sine of angle theta is always equal to opposite divided by hypotenuse. And we know that the cos of theta is equal to adjacent divided by hypotenuse. And we also know the tan of theta is equal to opposite divided by adjacent. These are our three trigonometric ratios that we have. Now, we want to answer number 1.1. This is just the information that comes from the diagram. Number 1.1 says, make use of the diagram to calculate the value of theta. We have two sides that are given, the opposite and the adjacent. Opposite and adjacent make up tan. Therefore, to find the value of the angle, we can use tan. The tan of theta is equal to opposite over adjacent. So the tan of theta is equal to 3/1, which means we can now determine the value of theta using a calculator. You definitely need a calculator to be able to work this one out. So tan theta is given, therefore we can find the value of theta using a calculator. Theta is equal to 71.57. This is coming from the calculator. That is my answer for number 1.1. Then number 1.2, I need to know that if you are given two sides in a right-angled triangle, then you can apply theorem of Pythagoras to calculate the third one. So the theorem of Pythagoras states that in a right-angled triangle where we want, let's say the hypotenuse is r and these other two sides are y and x, then the formula states that r squared is equal to x squared plus y squared. If I want to find the r, which is the hypotenuse, I add the squares of the other two numbers. If I want to find x, then I subtract. So this would be x squared is equal to r squared minus y squared. And in the same way, y squared is equal to r squared minus x squared. This is what the theorem of Pythagoras says. So in number 1.2, we want to find the value of r. So we can say r squared is equal to x squared plus y squared. Then we simplify the resulting expression. 1 squared plus 3 squared is 1 plus 9. That gives us 10. So this is r squared. Then we can square root both sides. It will give us r is equal to the square root of 10. When you are taking the square root of a number in maths, it's always a plus or minus. In this case, we take the positive one because r is the length of a line. The length of a line cannot be negative. Therefore, r is equal to positive root 10. That answers number 1.2. So the idea that is important here that we are reminding each other is that when given two sides and you want to calculate the third one, we can apply theorem of Pythagoras. That is the idea. Number 1.3, determine the following. This is determine the value of the following without using a calculator. Determine the value of the following without using a calculator, or determine the following without using a calculator. Now, how do we do that? We want to find the value of sine theta without using a calculator. This is directly connected to the diagram. You have to read from the diagram. Now, the sine of theta is equal to opposite over hypotenuse. So in our diagram, the opposite is equal to 3. The hypotenuse is r, which we just calculated in the previous question. So the answer to this question is 3 divided by the square root of 10. Without using a calculator, I have simplified the value of sine theta. It is equal to 3 over root 10. In some cases, you may be requested to simplify this answer further by rationalizing the denominator. Then you multiply the denominator, that will be by root 10, and you also multiply the numerator by root 10. This is rationalizing to remove the square root from the denominator. Then your answer will be 3 multiplied by the square root of 10 divided by root 10 times root 10, which is equal to 10. Question number A is done. Part B. What is the cos of 180 degrees plus theta? Now, this one needs reduction formulas. The moment you see 108 degrees plus or minus something, then you know that the 180 falls away, as well as the multiples of 180. So we can say 180 degrees plus theta, 360 plus theta, 720 plus theta, the 180 falls away. This is going to leave me with cos theta. But important now, if the 180 falls away, the resulting value become positive or negative depending on the cast rule. So in this case, cos 180 plus theta is in the third quadrant. In the third quadrant, cos is negative. So this is equal to negative cos theta. Then you substitute cos theta with values that are in your diagram. Cos is adjacent over hypotenuse. The adjacent is 1. The hypotenuse is the square root of 10. So the cos of theta is 1 over root 10. The negative 2 stays there. That is my answer for that question. So I may also want to rationalize this. In some cases, it's not a requirement. You can leave your answer like that. But if they ask you to not leave the square root like that, then you rationalize. Multiply by root 10, the denominator and the numerator. So the answer will become a negative of 1 times root 10 divided by root 10 times root 10, which is equal to 10. Then my answer is done. This is the answer to question number 1.3b. So diagram type questions, to quickly summarize what we have done here. If you are given a diagram that is half drawn, you complete the diagram by drawing a line to the x-axis and making an angle of 90 degrees. Then the coordinates that are given, you use those ones to label the sides of the diagram. The third side is calculated using the theorem of Pythagoras. The angles inside are calculated using trigonometric ratios, and all other calculations will be based on the diagram going forward. That is my answer. Done. Question 2. Determine the general solutions of the equation given. Determine the general solutions of the equation. So there is one video that I posted on general solutions only. It might be necessary to go have a look and study the whole component of general solutions. So what do we do here? If an equation is two different trigonometric expressions, there is a cos, there is a sine in the same equation, then and one of them is squared, then it means you must use the trigonometric identity to solve that particular equation. The identity we apply here is cos squared. We know about cos squared x plus sine squared x is equal to 1. This is the identity that we use to solve the equation. So I'll say it again. If the equation has a sine and cos and one of them is squared, then we can solve the equation by applying this identity. How do you go about it? You replace the squared one. Remove this squared one here and replace it. So from this identity, I can move sine squared theta to the right hand side. If I do that, then my equation will become cos squared x is equal to 1 minus sine squared x. It means cos squared x and 1 minus sine squared x, they are equivalent to each other, therefore they can replace each other. That's how you solve the equation. So let's do that and see what will come out. 2 factor of cos squared x is now going to become 2 factor of 1 minus sine squared x plus 5 multiplied by the sine of x. This is equal to 4. Now from here, you simplify the equation until simplest possible form. You simplify the equation until simplest possible form. So obviously the first thing is to remove the brackets, and then the brackets are removed by multiplication and simplify. So in a way, if there is a squared, think about quadratic equations. In a quadratic equation, we must express our equation in standard form. So we start with the squared term followed by x and then followed by the constant. So in this case, negative 2x squared plus 5 sine x. Then this 4, we move the 4 to the left to become negative 4. So it will give us 2 minus 4, which is minus 2. This is equal to 0. The leading value, you can make it positive by dividing your equation by negative 1. Then my equation will be 2 multiplied by sine squared are 2 times sine squared x plus 5 times sine x minus 2 is equal to 0. This is my equation. So it needs the ideas of quadratic equations. From here, you need to factorize, you need to apply quadratic formula, any method that you are comfortable with from quadratic equations. You are also allowed to introduce a different variable if you want your equation to look simpler. So we can say let sine x be equal to k. Then our equation will be expressed in terms of k. Sine squared x will become k squared. So this will be 2k squared plus 5 multiplied by k minus 2 is equal to 0. This is not a requirement, but it is something that you can do if you want your equation to look a bit simpler. Then from here, we can apply quadratic formula, we can factorize, or we can complete the square. You use any method that you are comfortable with. So for me, this can be factorized. So I'm going to factorize it. This is k minus 2 and this is 2k minus 1 equals to 0. So the first bracket gives me k is equal to positive 2 and the next bracket gives me k is equal to 1 over 2. Then I say therefore the value of sine x is equal to 2, or sine x is equal to 1 over 2. I have two separate equations that I must solve. The first one, the range, if you remember trigonometric functions, the range for sine x is from -1 to +1. So this value is outside the range. It therefore means this equation cannot be solved. Sine x cannot equal to 2. The only equation we need solutions for is the remaining one. The sine of x is equal to 1 over 2. Now, using a calculator, determine a reference angle. So my reference angle, this is direct calculator work using the calculator to determine the reference angle. Or for this one, you can tell what the reference angle is from special angles because we know about half. So our reference angle is equal to 30 degrees. Then after that, to determine your solutions, you look at the value that we have. Sine x is equal to 1 over 2. 1 over 2 is a positive number. So what it means is that you must get your solutions from the quadrants in which sine is positive. Determine the solutions from the quadrants in which sine is positive. So we know that sine is positive in quadrant 1. So in quadrant 1, if we may quickly go to the quadrants here. In quadrant 1, the angle is theta. In quadrant 2, the angle is 180 minus theta. In quadrant 3, the angle is 180 plus theta. In quadrant 4, the angle is 360 minus theta. Now your solutions are in the quadrants where sine is positive. That is quadrant 1 and quadrant 2. So the values of x there, in quadrant 1, x is equal to theta, and theta is the reference angle. X is equal to 30 degrees. In quadrant 2, x is equal to 180 minus theta. Theta is the reference angle. So x is equal to 180 minus 30. That gives us 150 degrees. Then to each solution, we add k times 360 to make it a general expression. Now we have solved the equation. These are the solutions for x. And in each case, k is an integer. These are my general solutions for the equation. So important, where did we start? We have to substitute the squared term with an equivalent expression that comes from the identity cos squared x plus sine squared x is equal to 1. Then we simplify our equation to standard form. After simplifying to standard form, we apply the quadratic formula or we factorize the equation or we use the completion of the square. Any method that you are comfortable with can be applied. Then you simplify the resulting equation to simplest form and then you can get your solutions. This is a question, a very common type of questions in grade 11, general solutions. Okay, let's have a look at question number 1.2. There is an expression there that we need to simplify for 5 marks. This is definitely 5 out of 5 marks. So there are two things here that we want to remind each other. The first one, if you see 180, the 180 falls away. Reduction formulas. Then if you see 90 degrees, 90 degrees falls away and it changes cos to sine and sine to cos. That is cofunctions. Then a negative sign, a negative angle. Negative angles are in the fourth quadrant. So in the fourth quadrant, cos is positive, but everything else is negative. So this is how our answer is going to look like. The first one changes into sine x after applying the cofunction one. The next one changes into negative sine x. It is a negative angle. So the negative for sine does not go away because sine is negative in the fourth quadrant. The bottom one, 180 falls away, it becomes cos squared x. This one, the cos of 180 plus x is equal to negative cos x. But because of the square squares the negative back to positive. That is why my denominator is a positive cos squared x. Then from there, I can carry on and simplify my answer. The top one, sine x multiplied by sine x, those two are going to give me a negative sine squared x. The denominator is cos squared x. I know something about sine over cos. Sine over cos is equal to tan. So the answer to this question is tan minus tan squared x. My question number 1.2 is answered. In general, the mark allocation here is not a prescription, but in general, the mark allocation follows the application of formulas. Ability to change the cofunction and then the negative angle and applying the reduction formula there, and then I get a mark for simplifying the expression and then for using tan. So that would be 5 marks for number 1.2. Reduction formulas, cofunctions, and so on. I must be able to answer these kind of questions for my grade 11 mathematics paper 2. All right, we have answered number 2, we have answered number. Let's look at question number 4. We want to prove the given identity. So when proving an identity, it is two expressions, one on the left and one on the right. So you must simplify one of them so that it looks exactly the same as the other one. If you work out the one on the left, it must look like the one on the right. If you work out the one on the right, it must look like the one on the left. That is proving an identity. So when you look at your identity, you have to choose which side to work with. So in an identity like this one, obviously, it makes sense that we can only simplify the left-hand side. Now, how do you prove an identity like this? This is very straightforward because it follows the basic ideas of mathematics. There are fractions here. The moment you see that in your identity you are adding or subtracting fractions, then you have to remember something about fractions. The basic ideas of fractions are that when adding or subtracting fractions, we make the denominators the same. When adding or subtracting fractions, we make the denominators the same. So that means I must multiply the fractions so as to make the denominators the same. So I have multiplied the first fraction by sine x. I'm going to multiply the second fraction by 1 plus cos x. Then from there, I simplify. Remember, in maths, when you multiply more than one terms, we use brackets and then we apply the FOIL method. Now, the moment I do that, everything will start adding up. So going forward, sine x multiplied by sine x. Those two are going to give me one value, sine squared x. Then the other fraction, this means the FOIL method. 1 times 1 is 1. 1 times cos x will give me cos x. Then cos x times 1, I get another cos x. And the last one is cos x times cos x. That will give me cos squared x. Now this whole expression is now under one denominator. I have made the denominators the same. Therefore, we can now add the numerators. And when you simplify the numerator. So from here, this is my expression and it carries on. Now, if you look at my numerator, I have to simplify by adding like terms. When working with identities, we know in identities that grade 11, we emphasize two identities, cos squared x plus sine squared x equals to 1. So when I'm working my identity, if I see cos squared x and sine squared x, or if I see this cos squared x or sine squared x, I must think of this identity. Sine squared x plus cos squared x, they equal to 1. Which means in this expression, if you take this sine squared x and that cos squared x, combine them, if you add those two, they give you 1. So I have 1, then there is 1 already there. Cos x plus cos x added, they are like terms. So they give me 2 times cos x. So if you look at what I'm doing right now, this is basic calculations. There is nothing serious that must give us problems. It's basic calculations. My denominator is the same. You keep it in brackets unless if it's so necessary to simplify it. The sine of x, factor of 1 plus the cos of x. Then carrying on simplifying, 1 plus 1 is equal to 2. So this is 2 plus 2 multiplied by cos of x divided by the sine of x, factor of 1 plus cos x. Then important to remind each other here, if you are working out an expression in maths that is addition or subtraction, you can simplify by factorizing it. In my numerator, there is a common factor of 2. So that gives me 2. If I factor out 2, I get 2. Factor of 1 plus cos x. Then in my denominator, I have the sine of x, factor of 1 plus cos x. After factorizing, you divide the common factor that you see there. There is 1 plus cos x on top, and there is 1 plus cos x at the bottom. Those two, they divide each other to give me 1. So the answer to this expression, on top I'm left with 2. In the denominator, I'm left with the sine x. Therefore, the expression on the left-hand side is equal to the one on the right-hand side. Therefore, my identity has been proved. This is proving an identity. So in general, We may quickly want to have a look at what ideas have we used here. It's very much important. If you have fractions a over b plus c over d, to add fractions, you make the denominators the same, or simply put, you can multiply b times d. That will become your common denominator, bd. Then you cross multiply the top times the bottom, a times d. That gives you ad plus b times c. You get bc. So this is my answer after adding a over b plus c over d. Another important idea that we may want to remind each other is that of factorization. Let's say, for example, I have an expression given. I have 2x plus 4y, and this is divided by x. These two cannot cancel each other. It is not correct to cancel, even though it looks convenient, we cannot cancel this x. The only time we can be able to do that is, let's say maybe there is a common factor. If there is a common factor, then we can go ahead and say there is x as a common factor on the top expression. Then this will give me x plus 2 plus 4yx. Then the x that has been factored out and the denominator, those two can therefore then be divided. This idea works all the time when doing trigonometry. Then lastly, another idea from algebra that works a lot when you are working out expressions. Let's say I have x minus y and I want to divide by y minus x. We apply factorization. We don't cancel anything here. What we do is we factor out negative 1 from one of the expressions. So if you factor out negative 1 from the top one, the first number becomes negative and the second one becomes positive. So if you write starting with the positive one, it will basically become y minus x. Then the bottom one is also y minus x. After this, then the common factor can be divided out and the answer is equal to negative 1. So when I'm doing my identities, I must have these general ideas from algebra that can also be applicable in working out the expressions. That's proving identities. We have proved this identity, and that answers the last question, number 4. Just to quickly summarize the question that we have answered, if you are given points, 1 point, and coordinates are given, we can use those numbers to draw a triangle. The first is the x coordinate. It is along the x-axis, and the second one is the y coordinate. So these two numbers, they give us two sides of a right angle triangle. We then calculate the third one using the theorem of Pythagoras. And to answer the questions that follow, we may need to use trigonometric ratios of right angles. Then if you see an angle added or subtracted from 180 degrees, that is the reduction formula. The 180 falls away. The resulting answer may become positive or negative depending on the cast rule. Then we solved an equation for general solutions. We said if there is a cos x and sin x put together in the same equation, remove the squared one and replace it with an equivalent expression that comes from cos squared x plus sin squared x is equal to 1. Then after substituting, simplify to standard form, use the quadratic formula or factorize to solve it. Then we also discussed that if you see 90 degrees, the 90 degrees falls away and the sine changes to cos and cos changes to sine. That is application of cofunctions. Then negative angles are in the fourth quadrant. So in the fourth quadrant, the negative for sine x does not go away because in the fourth quadrant sine is negative. The negative for tan x does not go away because in the fourth quadrant tan is negative. So in the fourth quadrant, it's only cos which is positive. Therefore, the cosine of negative x is equal to a positive cos x. Then be careful if an expression is squared. Squared basically means the answer is positive. Even though it was supposed to be negative, it is positive because of the squaring. Then the last one, we proved the identity by adding the fractions. A over B plus C over D is equal to AD plus BC divided by BD. When you are adding or subtracting fractions, you make the denominators the same. And as you simplify, you look for equivalent identities that you can substitute to complete your answer until the left hand side or whatever side you are working on becomes equal to the other side. Then your identity has been proven. These are the ideas tested in this question, Trigonometry Grade 11, Mathematics Paper 2.